At a highly anticipated technology showcase in Shenzhen, BYD's CEO Wang Chuanfu unveiled a groundbreaking innovation that sent ripples through the automotive world. A revolutionary internal combustion engine designed not merely to compete with electric vehicles, but to upend the very trajectory of the EV movement. This engine, long in development and shrouded in secrecy, promises fuel efficiency, performance, and emission standards so advanced that it challenges the prevailing assumption that electric vehicles are the undisputed future of transportation. Designed from the ground up, this engine defies traditional limitations of combustion technology. It operates on a novel thermodynamic cycle, integrating hybrid-like energy recovery systems and utilizing ultra-lean combustion to achieve an efficiency level previously deemed unattainable by internal combustion engine standards. Wang Chuanfu's presentation was confident, direct, and unusually assertive. Dressed in a dark suit, his tone fluctuated between passionate and provocative as he laid out the specifications. According to the company's internal testing, the engine boasts thermal efficiency exceeding 46%, eclipsing many leading-edge gasoline and diesel engines, and even edging close to some combined hybrid powertrains. It's not just about efficiency. Torque delivery, emissions management, and adaptability to synthetic and biofuels are all part of its disruptive appeal. Wang emphasized that this engine doesn't signal a return to the past but a bold leap into a parallel future, one where combustion can be clean, sustainable, and cost-effective. The crowd, consisting of industry insiders, engineers, analysts, and media personnel, responded with a mixture of awe and cautious curiosity. The claim was audacious. Electric vehicles have long been perceived as the inevitable successor to fossil fuel-powered transport, yet here stood a powertrain that seemed to undercut many of the EV movement's key advantages. The implications extended far beyond China. BYD, already a dominant force in global EV exports, was now proposing an entirely new chapter, one that could rewrite regulatory, economic, and technological assumptions across continents. A critical feature of the new engine lies in its fuel flexibility. Rather than tethering it to traditional gasoline, the system is optimized for next-generation fuels, including green methanol and synthetic hydrocarbons derived from renewable electricity. This allows it to slot seamlessly into global efforts to decarbonize transport without overhauling fuel distribution networks or sacrificing convenience. The engine also integrates what BYD calls intelligent combustion modulation, a real-time AI-driven calibration system that adjusts combustion parameters in milliseconds to maximize efficiency and minimize emissions under varying conditions. Beyond the raw technology, the strategy behind this launch is equally fascinating. Wang positioned the engine not as a rival to BYD's electric offerings, but as a complementary force, one that expands mobility access to regions where EV infrastructure remains sparse or impractical. From the highlands of Central Asia to the remote interiors of Africa and Latin America, charging networks lag far behind, and battery manufacturing remains resource-intensive. In such environments, BYD's new engine offers a compelling, alternative, clean, efficient mobility that doesn't require megawatts of grid capacity or rare earth minerals. The timing of the announcement was no accident. With global EV adoption facing headwinds, from stalled infrastructure rollout in the West to battery supply chain constraints and rising lithium costs, this engine positions BYD at a strategic crossroads. Rather than placing all its chips on electrification, the company is diversifying its technological arsenal. Wang's presentation also touched on durability and life cycle costs, emphasizing that the new engine has been designed for longevity, with fewer moving parts than traditional ICE units, thanks to an innovative modular design and integrated thermal management. The engine is expected to match or exceed the service life of electric drivetrains. Moreover, its manufacturability is highly scalable. BYD plans to produce the engine at multiple existing plants with only modest retrofitting, another nod to its practicality in an industry wary of overextending capital expenditures. The reveal has strategic implications far beyond BYD's own portfolio. For suppliers, governments, and consumers, the announcement reintroduces complexity into the narrative of automotive transition. Instead of a simple linear shift from gasoline to electric, the future now appears pluralistic. Countries with abundant renewable energy and robust grid infrastructure will continue to embrace EVs. But for the rest of the world, this engine offers a credible alternative that leverages existing logistics and reduces dependence on scarce battery materials. It doesn't apologize for burning fuel. Instead, It reframes combustion as a high-tech process capable of aligning with climate goals. For consumers who remain skeptical of EV range limits, charging times, or battery replacement costs, this development may offer a reassuring bridge, a high-performance, eco-conscious option without the perceived trade-offs of full electrification. The financial markets reacted with typical volatility. BYD shares initially dipped, likely reflecting confusion over whether the move signaled a retreat from EVs. But analysts quickly corrected course. As details emerged, it became clear that this was not a pivot but an expansion, a two-pronged strategy to dominate both clean electricity and clean combustion. Investors began to realize the implications. A company with a diversified propulsion portfolio is better shielded against raw material shortages, regulatory shifts, and geopolitical instability. Technologically, the new engine represents the culmination of decades of incremental and radical innovation. It incorporates elements from aerospace engineering, high-efficiency stationary engines, and Formula One combustion optimization. Yet it wraps all of this in a cost-effective, scalable package for everyday drivers. The rollout plan remains ambitious. Wang announced that the first production models featuring the new engine will hit the Chinese market within a year, with international expansion to follow. Strategic partnerships with fuel companies and infrastructure providers are already in place to ensure compatibility and fuel availability. Moreover, BYD plans to license the technology to other automakers, potentially making this engine a standard across a wide swath of the industry, if rivals are willing to adopt a competitor's innovation. While the unveiling focused primarily on the engineering and strategic dimensions, the cultural undertones were just as significant. In an era where the global automotive industry has often been led by Western or Japanese innovation, BYD's bold move asserts China's capacity not only to follow but to lead, and to redefine the terms of the debate. Wang Chuanfu, a figure who once stood in Tesla's shadow, is now carving his own legend and doing so on terms that blend pragmatism with ambition. The engine, in all its polished complexity, may well become a symbol of a new philosophy in automotive development, one that refuses binary choices between combustion and electric, legacy and future. Instead, it embraces nuance and multiplicity. At the center of this storm was the notion that combustion, once vilified for its role in environmental degradation, had been reborn in an unexpectedly clean and efficient form. The timing of this technological unveiling is just as critical as the innovation itself. Global narratives around energy, climate policy, and infrastructure investment are in flux, and BYD's announcement may redirect these conversations in substantial ways. One of the key dynamics influenced by this development is the structure of global energy policy. For over a decade, governments have operated on the assumption that electrification was the optimal path forward for reducing emissions from transport. Subsidies, incentives, and infrastructure projects have largely been designed around the deployment of electric vehicles and the retirement of fossil fuel technology. But BYD's engine introduces a compelling counterpoint. If a combustion engine can match, or even exceed, electric vehicles in terms of emissions and efficiency, then the rationale for exclusive support of battery technology becomes less solid. Some policymakers may now advocate for a more diversified investment strategy, one that includes support for synthetic fuels, biofuel production, and the modernization of combustion-based transportation. This shift in political and financial discourse is not hypothetical, it is already taking shape. International organizations and think tanks are revisiting their modeling scenarios to account for ultra-efficient combustion. Countries that had been reluctant to commit fully to EV infrastructure due to cost, terrain, or grid limitations are now seeing a viable path forward that doesn't rely on lithium mines or cobalt extraction. For example, nations with large agricultural sectors are looking anew at biofuels, considering whether they can now be paired with next-generation combustion engines to produce genuinely low-emission mobility. In these regions, the engine becomes more than a technology, it becomes a tool of economic self-determination. Moreover, the psychological and socio-political dimensions of the internal combustion revival cannot be understated. Many regions of the world harbor deep infrastructural and cultural ties to combustion-powered transport. Entire economies, from mechanics to fuel suppliers to logistics networks, are built around ICE vehicles. A technology that modernizes rather than replaces that ecosystem could ease the anxieties of millions who view electrification not as liberation, but as a potential economic disruption. In tandem with these geopolitical reverberations, The educational and research sectors will also feel the pull of this paradigm shift. For over a decade, engineering programs worldwide have heavily emphasized electric drivetrain design, battery chemistry, and software development for electric vehicle platforms. Now, with the resurgence of high-efficiency combustion, curricula may shift again. Thermal engineering, fluid dynamics, and combustion optimization could return to prominence in academic programs, with a renewed focus on sustainability and emissions control. Universities and technical institutions might launch new programs dedicated to hybrid systems and intelligent combustion, a merger of traditional mechanical engineering and modern AI-driven control systems. Energy companies too are paying close attention. While many have diversified into electric vehicle charging networks and battery storage, some are now evaluating the opportunity to invest in or partner with synthetic fuel initiatives. The ability to produce fuels that work seamlessly with new generation engines offers a commercially viable use for excess renewable electricity, which can be converted into hydrogen or carbon-neutral hydrocarbons via power-to-liquid processes. In this way, BYD's engine could also help address the intermittency issues of solar and wind energy by creating a massive new demand channel for surplus power. At the same time, insurance providers and safety regulators will need to reconsider how they classify and assess risk in this new technological landscape. Combustion vehicles have traditionally involved certain predictable hazards, such as fuel flammability, engine overheating, and mechanical wear. However, the new engine's modular construction, intelligent controls, and simplified architecture significantly reduce many of these risks. Regulatory bodies may soon begin crafting entirely new standards for these ultra-clean combustion platforms, acknowledging that they no longer fit neatly into old internal combustion engine categories. Safety certifications, emissions classifications, and even licensing rules may evolve in response. Environmental advocacy groups, historically skeptical of anything bearing the name internal combustion, now face a nuanced dilemma. While the legacy of pollution tied to old combustion engines cannot be ignored, the new engine's performance demands a reassessment. If life cycle emissions, including fuel production, vehicle manufacture, and end-of-life processing, prove lower than many current electric vehicles, the conversation around sustainable transport will need to be broadened. Some environmentalists may resist the idea, viewing it as a delay tactic in the march toward electrification. Others, however, might embrace it as a necessary and equitable solution for parts of the world where batteries remain an impractical option. Consumer behavior is also likely to shift in unpredictable ways. The last decade saw a rising cultural attachment to electric vehicles, from their sleek branding to their association with technological sophistication and environmental virtue. But if combustion engines can offer comparable performance, lower life cycle emissions, and greater long-distance flexibility, consumers may begin to re-evaluate their choices. This shift could be particularly pronounced in rural areas, cold climates, and regions with limited charging access. Buyers may start seeking out vehicles powered by the new engine as an expression of both pragmatism and environmental responsibility. Dealerships and vehicle service networks will benefit from this change as well. The slow rollout of electric vehicle service infrastructure has left many dealers in limbo, caught between supporting legacy vehicles and adapting to an all-electric future. With BYD's new engine, service providers can modernize their offerings without abandoning their skill base. The engine's simplified design and predictive maintenance features may even reduce service frequency and complexity, improving margins for dealers and convenience for customers. Fleet operators, logistics companies, rideshare networks, and public transportation authorities stand to gain considerably. Many have faced challenges scaling EV fleets due to charging logistics, limited range, and downtime. An ultra-efficient combustion engine allows for the deployment of vehicles with predictable refueling patterns and high endurance, especially important for 24-hour fleet operations. BYD's initial focus on fleet customers may accelerate adoption, demonstrating cost savings and performance metrics in high-demand environments before trickling down to private ownership. Within the automotive industry, design philosophies may also evolve in response to this breakthrough. Electric vehicles have often dictated a particular layout: flat floors, battery packs under seats, and aerodynamic bodies designed to maximize range. The new engine, being compact and modular, introduces new possibilities. Designers may enjoy greater flexibility in vehicle aesthetics and ergonomics, creating models that blend the best of combustion and electric form factors.